So my target is to cover Unit 3 from the course material, and then by tomorrow we are to cover hopefully Unit 4. So Unit 3 is just to point you to certain things, That is exactly what we have in Unit 3. So in Unit 3 we will look at integers, we look at rational numbers. So let me just write them out. The first, we're looking at integers. The second, we're looking at rational numbers. The third, we're looking at natural numbers. Look at natural numbers. Then also we are going to look at irrational numbers. Irrational numbers. Number 5, decimal numbers. The 6th one is real numbers. Number 7, we look at inequalities. Number 8, we look at absolute value. Then we look at intervals. Then we look at bonded sets. 11, unbounded sets. So those are actually what we intend to cover today. From Unit 3 of the course material 106. So the essence of this particular unit is actually going to, I'm going to explain these 11 items that we have on the board. I will explain them one after the other. So I want to give a rapt attention to my explanations, because if you understand this particular 11 things outlined in Unit 3, you will be able to deal with the remaining units. You see, all the things we've been doing so far in sets. Unit 4, I was actually wondering why they had even had to include Unit 4, the content of Unit 4 in the course material, but I think it's also fine because Unit 4 is about functions. But let us deal with this first. I'm going to give you the meaning of each of these points that we have on the board. Each of them, I will explain each of them to you and the role they have to play. So give me your attention. So if anybody comes in late, I'll just refer you to the recording. So this time I'm not going to drop the recording in the form of based on demand. I'm not going to drop it in the form of a link from Google. I'm going to drop it as a YouTube link. So I have another device taking the live recording, so that will be uploaded right away to YouTube, and then the link will be dropped for us to use. So the first we want to take now, we are going to take the first one. Let us take the first one. Let's take the first one. We are going to take the fourth one. So, integers. Integers are whole numbers. They are whole numbers. I want you to take note of that. Integers are whole numbers, and they include both positive and negative, both positive and negative values. So take note of this: positive and negative values. as well as 0, as well as 0. So that is what integers actually, so they are whole numbers. First thing I want you to know is that they are whole numbers. Integers are whole numbers, and they include both positive and negative values. So what it means is that integers can either be a positive number or a negative number. Or maybe we put it this way, it can either be a positive value or a negative value. It can be either a positive value or a negative value. Take note, they are not fractions or decimal So integers are not fractions or decimal numbers. They are just whole numbers. Whole. That means they are full numbers. So, and it begins from 0. It begins from 0. So we can, zero is included, not just begin. It doesn't begin from 0. 0 is included. So integers can either be negative or positive numbers. So we can say an example, for example, of integers. Say -4, -3, -2, -1, 0, 1, 2, 3. So you see the minus here, they are what? They are expressions of negative values. These are negative values. 0 is included. So if you actually want to arrange numbers in a particular order, if it starts from the negative value, it gets to, after -1, it gets to 0, 1, 2, 3, and that is just how it goes. Usually, sometimes it is represented in a number. They call this a number line. It could be represented. My line may not be too straight. It could be represented using a number line. The number line, the center point is 0, and maybe this, based on how it is scaled. This is called a number line. So the number immediately after, just after 0 by your left hand side will be a -1, followed by -2, followed by -3, followed by -4, followed by -5. I mean, it keeps going. It keeps going. And then at the right, immediately after 0 is 1, 2, 3, 4, 5. I mean, till infinity, actually. Till finite. You understand? Infinite. So it keeps going like that. That is how to know and understand integers. So integers, I've said that integers, they are not fractions or decimal numbers. What that means is that they do not include fractions. What are fractions? These are examples of fraction. 2/3 is a fraction. 1/2 is a fraction. 5/2/3. This is a fraction. You understand? Even though it is an improper fraction, we have two types of fraction. We have proper, and we have improper. We have improper fraction. So, and they are also not, integers are also not decimal numbers. Examples of decimal numbers is 2.3, 2.35, 1.5, 6.7, 3.2. I mean, any number that has a decimal point. Another example could be 0.01, 0.33, I mean, and so on and so forth. So these are decimal numbers. So what I'm trying to say is that integers, they are not decimal numbers and they are not fractions. I want you to take note of that. So for example, yes, please.
Sorry, good evening. Sorry, I want to know, is the class being recorded?
And it's recorded. It's recorded.
I think there's something that is blocking the screen. I cannot view the lower part of the board.
Okay, I will take it up. I'll take it up because the other thing blocking the screen is the next camera that is recording the class, that is taking a full vocal view of. So I will take it up now. Sorry, I'll take that up. So the class is recorded. So let me take this up. So I said that integers, they are not fractions or decimal numbers. Example of a fraction is 2 over 3, 5 over 7, maybe 2 over 3. So, and I said there are what we call proper and improper fractions. So we have two types of fraction, but that's not what we came to talk about today. So we have two types of fraction. We have proper and improper fraction. And also integers are not decimal, excuse me, they are not decimal numbers. Example of decimal number is 2.3, 2.5, I mean 0.01, 0.33, and any number that has a dot. Maybe I should use that language to make it easier to understand, to comprehend, with a dot. Any number that has a dot, this is actually called a what? A decimal number. So how do I identify an integer? This is the question now. An integer is a whole number. First of all, it is a whole number. So you see this fraction now, 2 over 3 is not a whole number. 2 over 3 is not a whole number. It is actually kind of incomplete. It is not a whole number. It is not a whole number. Did you get that? Integers are just whole. They are just 1, 2, 3, maybe 22, 32, for example, and 22, 15. These are whole numbers. So it continues like that. It continues like that. Excuse me. Did you get that? Did we all get that? Hello? All right. All right. Can you all hear me? Roland, can you hear me? Hello? Hello? Yes, I'm coming back now. It's a network. It's a, sorry, data that I was out, so I just recharged. It's coming up now. Sorry. Yes. All right, sorry for that break in transmission, like they will always say. I guess it went out on data. So can we continue? Can you see my board? Can you all see my board clearly?
I can see your board.
All right, very well. So let us proceed. So I was talking about integers. I've actually given examples of integers. The integers are whole numbers. They are whole numbers, and they are both positive and negative. So they can either be positive or they can either be negative. And it also includes the number 0. It also includes the number 0. So those are integers. So now let us look at the second one, the second on the list. Let us look at the second on the list. The second on the list is rational numbers. The second on the list, rational numbers. Like we said, that integers are whole numbers. They are complete numbers. They are not improper numbers. They are not incomplete numbers. They are not fractions. They are not decimal numbers. Integers are whole. They are complete. Now, rational numbers are also types of numbers that can be expressed. They are numbers rational numbers are numbers that can that can be expressed as a fraction. So you see the difference between integers and rational numbers. Integers are not expressed as fractions, but rational numbers are expressed as fractions. And it does not just stop there. It also says where the numerator and the denominator. I'm going to explain that. The numerator and the denominator are both integers, and the denominator is not 0. The denominator is not 0. So rational numbers, take note of these things. These are the things I want you to take note of. A rational number is expressed as a fraction, so that means it is a fraction. But where it is a fraction, it has a numerator and a denominator. 2/3. This is the numerator. This is the denominator. So you can understand it. The number below is the numerator. The number above is the denominator. So rational numbers, they are expressed as fraction. It is actually a fraction expressed in the form of a fraction with a numerator and a denominator, but the numerator and the denominators are both integers. So you can see, you connect this now to integer. What is an integer? An integer is a whole number. So you can see now the numbers that we have here, they are whole numbers. And the only difference here in this particular part, integer coming into rational numbers, is that, and the denominator is not 0. The denominator, the number up, the number that is up, is not what? 0. Did you get that? Is not 0. So, for example, this is another example. 1/2. 1/2. Another example of a rational number. It can also, take note, it can also be, since an integer can either be negative or positive. So a rational number can either be negative or positive, but it must not be 0. Take note of this. This is what you need to take note of. So it can be this, for example, 1 minus 1 over 2. This is what? This is a rational number. So you can never have a rational number in this form. This is not a rational number. Do you know why? 0 divided by 2 is equal to what? 0. So when you divide 0 by 2, it no longer becomes a rational number, because a rational number is only expressed as a fraction. So if you do 0 divided by 2, 0 divided by 2 is equal to what? 0. Or 2 divided by 0 is equal to what? 0. So this now takes you back to what? Integer. So it is only an integer that has 0 amongst the list of whole numbers. I don't know if you got that explanation. Did you all get that explanation? Yes, James. Yes, James, very quickly, please. Very quickly.
Hello, can you hear me, sir?
Yes, I can hear you.
Okay. The rational numbers. I want to ask, because I've seen fraction there. I want to ask, can we both use both proper and improper fraction on it? Like,
sure. Yes, they are.
I'm not asking for illustration. I'm just asking if you can be considered.
Of course. Yes. So rational numbers.
Hello, sir.
Yes, I heard you clearly. I heard you clearly. So the first thing you need to take note of, let me respond to your question, is that rational numbers are expressed. They are expressed as a fraction. So whether they are expressed as a proper or improper fraction, it is what? It is actually what? A rational number. It is actually a rational number. That is the first thing I want you to take note of. So whether it is expressed as a proper or improper fraction, it is actually a what? A rational number. Yes, any other question? Any other question around that? So take note again, another thing you need to know is that a rational number, they are real numbers. They are real. They are real numbers. They are not just numbers like that, but they are real numbers. They include real numbers. I'll give you some other examples of rational numbers. I'll bring up some other examples of rational numbers. So I've said that rational numbers include fractions.
Hello, sir. Can I ask a question?
Go ahead and ask.
Okay, based on your explanation, what if the numerator is 0? Does it still reflect that it's a rational number?
But that is what I just explained now, that if the numerator is 0, if it is 2 divided by 0, for example, 2 divided by 0 is equal to 0, because a rational number is not, 0 is not included. 0 is not included amongst a rational number. Did you get that? So if we have what? 2 divided by 0 is what? 0. 0 divided by 2 is equal to what? 0. Did you get that?
It's clear.
All right.
Yeah, thank you.
Thank you very much. All right. So let us push on. Let us go ahead. We also have, so let me say, examples of rational numbers. Examples of rational numbers. So because rational numbers are expressed in the form of fractions, we can also say that rational numbers are decimal numbers. For example, if you have 5 over 2, this is actually a fraction. Am I correct? This is a fraction. So if you divide 5 by 2, your answer is going to be what? 2.5. So we can as well say that 2.5 or rational numbers are also expressed as decimals. Did you get that? Rational numbers are also expressed as decimals. So another example of a rational number is what? They are decimal numbers. So examples of rational numbers. Examples of rational numbers, we have fractions. You can say A, fractions. You can say B, mixed numbers. That is the question James asked. The question James asked if we can also include improper fraction as then we have decimal numbers. We have decimal numbers. They are all rational numbers. They are all rational numbers. So, for example, 0.6, 2.5, 3.2. These are all rational numbers. Then mixed numbers. Example, we have mixed number could be in the form of 2, 1 over 2. That's an example of a mixed number. Another example of a mixed number is 5 over what? 2. Which is the same thing as this. So those are mixed numbers. So fraction, example of fraction is 2 over 3, 3 over 5, and maybe 6 over 7, just like that. Those are examples of fractions. Those are examples of fractions. So rational numbers are expressed as a fraction. They are always expressed as fractions. Take note of that. But even if they are expressed as fractions, the numerator and denominator, they are both integers. Integers, it means they are whole numbers. They are whole numbers. And the denominator is not 0. Why? Because if you divide 0 by any number, the result is actually 0. So, and 0 is an integer. 0 is not a rational number. I hope we all got that clearly. Because I'm moving to the next one. So I'm taking this out.
Yes, sir.
Sorry? Are you saying it's clear or you wanted to ask a question?
I said I'm clear.
All right. Okay. Thank you. Thank you, James. So the third on the list there is natural numbers. Natural numbers, they are also known as counting numbers. These counting numbers, they are positive integers. They are known as counting numbers. Natural numbers are known as counting numbers. Positive. Apart from being counting numbers, they are positive. Take note of that. They are positive integers. I hope you remember what integers means. They are positive integers. Starting they start from 1. They start from the number 1 and count indefinitely. It counts indefinitely. They count indefinitely. You know, because this is somehow connected to sex, so they are often denoted. They are often denoted as n. 1, 2, 3, 4. Did you see that? That is how a natural, not rational now, a natural number is expressed. They are known as counting numbers. That is how rational and natural numbers are known as. They are known as counting numbers. And these counting numbers, the counting starts from 1, not from 0. Remember that concerning integers, we have 0 somewhere amongst them. it does not start from 0, but it has 0 amongst it. You know, when I draw a number line to represent integers, how integers are arranged, it starts from the negative. It could either be a negative number or a positive number with 0 within the midst of it. But natural numbers, they are known, they are classified as counting numbers, and they are positive. This one now does not have a negative value amongst it. So all natural numbers are positive. So I want you to take note of that. They are not just positive, they are positive integers. Take note of that. That's one thing I want you to take note of. They are positive integers. And it starts from the number 1 and counts to infinity. So remember we did this in set in the previous unit 1 and 2, infinity. You know, when you write within the elements of a set. So n here represents natural n. So it is denoted as n is the curly bracket there, 1, 2, 3, whatever. It goes indefinitely. It keeps going. It doesn't have an end. That's what that actually means in respect to natural numbers. So we can say examples. I think I've already given the example there. So examples of natural numbers. So we have n, curly bracket, open 1, 2, 3. This is a natural number. This is actually a rational number. So I can say example. This is example A. Example B is successive numbers. Successive numbers are examples of natural numbers. Did you get that? So, for example, say 7 and 8. 7 and 8 they are successive numbers. Somebody may be asking, what does that mean? 1 and 2, they are successive numbers. 2 and 3, they are successive numbers. So that is, it keeps counting. It counts. It follows a particular order. Did you get that now? It follows a particular order. So 7 and 8 is a successive number. So that is 8 is actually succeeding 7. Yes, James, your hand is up. Go ahead, James.
Sorry, sir. Sorry for taking you back. I don't know if you stated it before or maybe because I joined late. So what I'm trying to ask is this concerning, we have, I believe you talk about real numbers and rational numbers. So if we are to come across real numbers and natural numbers in exam or maybe in any way, are we going to know that maybe what are the symbols that are used to denote real numbers and rational numbers? Are we going to identify it that this is real numbers and this is a symbol for rational numbers and as well as these natural numbers?
Okay, take note, I have not talked about real numbers yet. The first number I talked about, the first type of number I talked about is integers. I've talked about integers. This is the third one, and I've talked about rational numbers, and now I am talking about natural numbers. I'm actually going to talk about real numbers, but don't bother yourself about how they are denoted. The first thing you need to know, the reason why I'm taking our time to give explanation in respect to the definitions of each of them, this is where you actually need to get it straight. For example, when I say integers, I said integers, they are whole numbers. That's the first thing that should go. So that is why you see me keep underlining a particular part. Integers are first, they are whole numbers. After being whole numbers, they are both positive and negative. So even if they are whole numbers, they are positive and they are negative. So apart from being positive and negative, they are also not decimal numbers and they are also not fractions. That is how, like you are asking in your question, how do we identify? If I should get your question rightly, your question is saying, how do I identify a real number? How do I identify a natural number? How do I identify a real number? So with what we have learned so far, the way to identify an integer, first of all, you should know that it is whole. It is whole, as in it is complete. It is not, in fact, the main thing you need to know is that it is not a fraction and it is not decimal. So anything around fraction and decimal, so integer will say don't count me in. Fraction, decimal is not integer. So if you have a question like this, like you are saying, we come across it in the exam hall. So if you come across something like this, is identify the integer from the list of numbers. A 2.25, B minus 3/2, C 0.3367, D 5/1/2, and E 0. So now let me ask James, identify the integer among the list of numbers there.
Okay, the integer among the numbers are B and C.
Okay.
Sorry, are B, yes.
All right.
B.
So this is actually to express that you have not yet understood what I explained. And I'm going to take it again. Integers. So one thing I want everyone to do in class now is to take note of everything I am writing on the board. That's why I'm taking out time to write it on the board. So integers first. James, take note of this. Integers. Yes. Integers they are whole numbers. They are whole numbers. Take note. First, they are whole numbers. That's first point. Second point, they are both negative and positive. This is actually short form. Negative, positive is short form. And they are not decimals. Decimals and fractions. Did you get that now? So these are the 3 points you need to note concerning integers. So that is why, like I've always said, is when you enter into the exam hall, move in with confidence and pay attention to details. So it is not like James does not know it, but she did not give attention to details. That is what I would say. So the integer, the first thing you need to know when they say identify the integer from the list of numbers, identify the integer is actually telling you that we have just one. It is just one. So that is how to actually read the question and understand, oh, what are they talking about? They're actually talking about one. So identify the integer from the list of numbers. So there are different types of numbers that we have among this list. 1, 2, 3, 4, 5. There are 5 numbers, but we need just one. The integer is, they call this definite article in English language. I always talk about the English part of mathematics. So you say the integer. Okay. What is the first question that should come to your mind is that what is integer? So this is where this now comes to play in your mind. Integer is a whole number first. It is either it is positive or negative. 2, then it is not decimal and it is not a decimal number. It is also not a fraction. So you look at this one. This one is decimal. So this one is out. This is a fraction. This is out. This is another decimal. So this is out. This is a fraction, even if it is an improper fraction, so it's out. So this one now is what? Is a whole number. Remember, okay, point number 4. Point number 4 is out. So 0 is included. 0 is included. So this is now your what? Your answer. So that is just how to get it right. James, did you get that now?
Yes, sir. Thank you, sir.
All right, very well. So I hope everybody got it. So the whole thing is just grab every point that is stated. Once you grab every point, every other thing is just going to be very easy for you to handle. So let's take the fourth one. Any other person with any question before we take the fourth one? Any other person with a question? Okay, yes. Ola, go ahead. Yes, Ola, go ahead. Yes, welcome. Good to have you, Ola.
Thank you very much, sir. Good evening, class.
Good evening.
Yeah,
welcome.
so based on the definition of that integer, so
yes,
both negative and positive. So -1, -2, -3, -4, they are also integers too, right?
Very well, very well. Yes, yes. All right, thank you. All right, so O2, go ahead.
Good evening, sir.
Yeah, good evening, O2.
Network contributor. I want to ask, you were trying to say 7 and 8 are successive numbers. Am
yes,
I right?
Yes, yes.
Thank you.
Very well. All right, so that's a very good question. I like that kind of question. It's just straight to the straight to the point. So now let's take irrational numbers. Irrational numbers. So irrational numbers first. They are real numbers. Irrational numbers. They are first what? Real numbers. They are first real numbers that cannot be expressed. They cannot be expressed. 2 points there. First, they are real numbers. Second, they cannot be expressed as a fraction. Or ratio of two integers. So you can see somehow the other types of numbers, they have a kind of connection with integers. So look, I will tell you for real that it is important that you understand this man. So you actually need to put this man into your head. You need to know what this man means. If you know what this man means, it will help you to be able to handle the others. So now we are told that irrational numbers, they are real first. They are real numbers. They are actually real numbers. Not just being real numbers, though we are going to talk about real numbers as we go further. Real number is the sixth one. So irrational numbers are real numbers that cannot be expressed as, they cannot be expressed. So in other words, they cannot be expressed as a fraction. They cannot be put as a fraction or a ratio of two integers. They cannot be expressed as a ratio of two integers. They have no, so let me continue there. Take note of all the things I'm writing. They have no repeating non-terminating decimals. That is another thing about, irrational numbers. Irrational numbers. First, they are real numbers. So take note of this. First, they are real numbers. Secondly, cannot be expressed as a fraction. It can also not be expressed as a ratio of two integers. It cannot be expressed like this. Let's say 2:4. This is a ratio. This is what we call ratio. 3:5. So irrational numbers cannot be expressed as a ratio of two integers. This is an integer, this is an integer. It cannot be expressed like this. maybe another one, 2 ratio. So remember we said that integers can either be positive or negative. That's why you see me putting the positive, the negative there. So they cannot be expressed as a fraction. So rational numbers cannot be expressed like this. So this already is out of what? A rationality, cannot be expressed as a fraction or ratio of two integers. They have no repeating, non-terminating decimal expansions. So examples of rational numbers, they include, let me just write them out. Examples of rational numbers. Let me just say examples. Example 1, the square root of 2. Square root of 3. The square root of 4. The square root of 4 is not an irrational number. Why? Because when you find the square root of 4, what is the square root of 4? Are we there? What's the square root of 4? 2. What's the square root of 36? 6. So they are actually this, you cannot call this what? An irrational number, because the value, the returning value is, they say they have no repeating, non-terminating decimal expansions. So this one now, they continue. That's just what it means now. So if you write this as a rational number, it is actually not rational, because you can actually find the square root of what? Of 4 to give you an integer. Did you get it now? To give you an integer. So remember that an integer, so you see, I want you to get something there, because this one might look a little bit confusing. An integer, that is why I said you must always know what this means. An integer is a whole number, a complete number. So if I find the square root of 2, what is the square root of 2? If you have your calculator there, check it for me. Or check it yourself. What's the square root of 2?
Minus 2.
Square root of 2. Square root of 2. The square root of 2.
2.
No? Square root of 2, not the square. The square root of 2. You should know how to use that in your calculator.
1.
No?
1.4.
Yes?
1.4.
What did you say?
1.4.
1.4. That's exactly how it is. So the square root, so please try to get to know how to use your calculator to find the square root. The square root of 2 is what? Is 1.4. So what is this now? Is this an integer? No, it is not an integer, because the returning value is a decimal number. Do you understand it now? The returning value is a decimal number. The returning value for this square root of 36 is a perfect square. This is a perfect square. This is an imperfect square. So because it is imperfect, because when you find the square root of that particular number, you get it results to a decimal. Roland, find with me from your calculator the square root of 144. Square root of 144. Sorry? 12, exactly. 12. So the square root of 144 is what? 12. It did not return it as a decimal number. So the result is actually a whole number. That's what I want you to get now. Is a whole number, is complete. It did not return it in the form of a fraction or in the form of a decimal number. So irrational numbers, they cannot be expressed as a fraction. they cannot be expressed as a fraction. Another example of irrational number is pi. Pi is a value. This is a value. So it can be what? 3.142 pi. Or sometimes they call it 22 over what? 7. The value of pi is equal to what? 22 over 7. Do we know this? I mean, we must have known it, seen it in our, even if you are not a science student, you saw it in primary school. Sorry, in JSS 3 or JSS 2, you saw this now. So when you want to find the area of a square, this is pi r square. Do you remember that? So this is an example of a rational number. Irrational number. Did you get that? Did you all get that, please? Did you all get that? So let me assume the quietness is that we all got it rightly. Okay. Yes, the quietness is that we got it rightly. So we're taking the next point. The next one. The next one, the next we have on the line, number 5. Are we number 5? The next on the list are called decimal numbers. Though I have mentioned it in the course of my explanation, even if I have not defined it or deeply explained it, but at least I have shown you examples of decimal numbers. So, but what are decimal numbers? Decimal numbers are numbers expressed in base 10 system. They are expressed in base 10 system with the decimal point. Now take note. Another thing I want you to take note. Look, it is very important you get the words, the exact words on your course material. Now, the things I write here, they are actually for explanation purpose because you actually called me to tutor. That is to impact knowledge. So what I am doing now, I'm impacting knowledge. So sometimes you may not see it the same way I have written it on the board or the same way I have explained it in your exam. But the essence of what I am doing is actually to make you understand. So if you understand, because sometimes most of the explanations in the course material are, like I've always told you, it is called a course guide. So the material you have, whether soft copy or hard copy, is actually a guide. It's actually meant to guide you, to show you how to do this thing, to guide you. And that is why they provide for you what we call reference material. So at the end of each unit, some people don't even bother looking at their course materials. I don't know why, but I advise you that you always read through it. So at the end of each unit, they always provide reference materials, maybe some textbook that you can buy or maybe borrow, or look for them. If you're actually looking for some books, you can reach out to me. I can help you with some. I have some, you understand? Or maybe I will even drop most of them on the platform so you can use them to help you to understand better. That's just the best way to. So it's a guide. So it guides you and tells you this is how you should do it. So it may not give you elaborate explanation. So what I am doing, so that you don't get me wrong, what I am doing is actually to tutor, to impact knowledge. So when you understand it this way, when you look at the course material, it becomes very easy for you because the course material is actually to guide you. Thank you. So let us go ahead. So decimal numbers are numbers expressed in base 10 system. I said that because you may not see it exactly the way it is here in your course material. They're expressed in base 10 system with a decimal point separating the whole part from the fractional part. Separating the whole part from the fractional part. So that is what decimal numbers look like. So example of decimal numbers are examples of decimal numbers is 3.14, 2.66, 1.333. And take note, another thing I want to quickly bring to your light now, okay, maybe another example, 0.7. And like if we have 5 divided by 2, like I said before, the value is what? 1/2 or 2.5. So 1/2 is actually what? A 0.5. Half is a 0.5. Did you get that? So that is why it's saying that it is with a decimal point separating the whole part. This is the whole part. Let me take this again now. So 5 divided by 2. 5 divided by 2. Let me do children mathematics like we used to do those times when we were small. We count 1, 2, 3, 4, 5. You say divided by 2. You count 1, 2, 1, 2. So you say 2. 2 remainder 1 over this 2 here. Are you seeing that? So you've expressed this like they used to tell us in primary school. It says express this proper fraction as an improper fraction. This is the expression of this. That's how we used to do it there. So a decimal number, you can be told now to express this in base 10 system. To express this in base 10 system now, what this actually means, you bring 2 first. You bring 2, you put the 2, which is separating the whole part. This is the whole part. 2 is the whole part. So you are separating this whole part. You are separating 2 from this other part of the fraction. So you express the whole part of the fraction, the fractional part. You express the whole part from the fractional part. So this is the whole number. You bring the whole number. So what is this one now? 1/2. 1 divided by 2 is actually 0.5. It's actually 0.5 if you punch it on your calculator. So which is the what? The point. So you bring the point and you put 5. So this is what decimal number actually means. That's what decimal number actually means. So, but don't break your head about all these things I have just done now. I'm just trying to tell you, in fact, what you should know is that decimal numbers are numbers that has the whole number separated with a dot from the remaining numbers. So the whole number, it must be whole number first, or integers. So this is 0.7 now. This is a whole number. A whole number is an integer. 22.5, 35.66. This is the whole number, this is the whole number, this is the integer separating from the other part of the number with a point or with a dot. Did you all get that? Hello? Are we there?
I got it.
Sorry, sir.
All right. Okay, that's very beautiful. So that is just what to know about decimal numbers. Other examples of a decimal number is 55.25 kobo. This is another example of what? A decimal number. 55 naira, 25 kobo. So they use a dot to separate the whole from the part. So this is the part. This is the what? The whole. That's another example of a whole number. For example, you go to the hospital, they say, they check Mr. Jacob's temperature, and they say, his temperature is 35.6 degrees Celsius. This is the whole number, this is the other part. So those are examples of what? Decimal numbers. Those are examples of decimal numbers. Did you get that? So that is just how it is. So let's go to number 6.
I'm sorry, sir, I have a question.
Please go ahead. Yes, go ahead, please.
Okay. How do you express 8.5? This is as a whole number.
Okay, the first part I didn't hear you, so take it again. Take it again.
Okay, I said to express this 30, so this 22.5 as a whole number and 35.66.
Okay. Okay, if I got you rightly, how do you express this? This is 22 1 over 2. This is 22 1 over 2, which is equal to 22.5. Did you get that? 22.5. This is expressing it as a whole.
Okay. And what about the 35.66?
Okay, the 35.66 would be 1 over, that is 1 over 3, maybe 3, 1. If you divide 1 divided by 3, it could give you, so somebody divide 1 divided by 3. 1 divided by 3. One divided by 3. 0.33. Did you get that? So, look, the message is just, yes, trying to know how to express in decimals. Decimals are always separating the whole number from the other parts of the numbers. That is what decimal numbers are. So the number 6, real numbers. I think that takes us to where, what's her name? James was asking us about real numbers. So real numbers are actually all rational and irrational number. So rational and irrational numbers actually make up real numbers. So the first thing we need to know is that you now need to know what a rational number is and what an irrational number also means. So we said earlier that rational numbers are numbers that can be expressed as a fraction. Rational numbers can be expressed as a fraction. And irrational numbers, they are numbers that keep counting as counting numbers. Irrational numbers are real numbers that cannot be expressed as a fraction. Rational numbers are numbers that can be expressed. Take note of two things now. Okay, let me just define real numbers. So real numbers encompasses rational and irrational numbers. But the first question you need to know, what is a rational number? And then what is irrational numbers? I had said that the rational number are expressed as fractions. Irrational cannot be expressed as fractions. Did you get that? So you must know the meaning of rational and also know the meaning of irrational. So real numbers are made up of, or they encompasses rational and irrational numbers. That's what they are made up of. So we can say, in other words, real numbers okay, let me take out this. Okay, I had to take out a base 10 number system because I've already mentioned decimals. That's why I took out base 10 number system. So real numbers are numbers made up, they encompass, they are made up of rational and irrational number. And I've just taken out time to repeat, to do a repeat explanation of what is a rational number and what also is an irrational number. I said that rational numbers are expressed as fractions and irrational numbers cannot be expressed as fractions. So in other words, real numbers now includes integers, they include fractions, they include decimals, they include non-repeating, non-terminating decimal expansion. So real numbers are made up of both sides. So it can either be a fraction, it can also not be a fraction. That's what it means. So let's take some examples. Examples of real numbers. We have 2/3. This is a fraction. 2/3 is a what? Is a fraction. Then the square root of what? 5. What's this now? What's the square root of 5 there? Not the value. What do we call the square root of 5 there? Not the value. I'm not saying you should calculate it now. Yes, Mr. Jacob. How do we call the square root of 5? Okay, Memunat wants to say something. Memunat, go ahead. Good enough. Your microphone is good today.
It's rational, sir.
Very well.
That is.
Yes.
Yeah, rational.
What did you call it?
Rational, sir. Can you hear me?
No, irrational.
Irrational.
Yes. It is actually what? Irrational. Do you understand? So, the square root of 5 is irrational. Take note of that, please. Don't forget. It's irrational. So, 6. For example, 6, 7, 3, 0. What are they?
Integer.
Sorry? Okay, Ola. Yes, Ola. Ola's hand is up. 6, 7, 3, 0. What are they? Integers. Excellent. All right. Integers. You see that? So, look, real numbers, they encompass. So we can also say, can we say that -2, -7, minus 3. Are they also real numbers? Yes, they are also real numbers. So 2.6, 2.7, 3, 0.5, they are also part of what? Real numbers. So they make up, they just gather there together. They are not, they are all real numbers. Did you get that? They are all real numbers. So real numbers, as in the name implies, they are all real. They exist. They are there is nothing like it does not exist. It exists. Real numbers exist. So real number exists. We have really taken so much time. I'm going to stop at I'm actually going to stop at inequalities. So let me take the last one, inequalities. I hope we all understand this. Yes, O2, go ahead.
Real numbers, they don't have 0.
Yes, 0 is there now. I wrote 0 somewhere here. This 0 is an integer.
Okay.
Yes.
Okay.
All right. So I'm going to round up with this now. Inequalities. So I've really taken time. The last number 7. Please mute your microphone. Inequalities. That's the next on the list. The next on the list, we actually had 11, so we've done 7. So that is where we are going to stop because I have another section. This is already 6:50. So inequalities. Inequalities are mathematical statements. First, you need to know is that they are mathematical statements So inequalities are mathematical statements that compare two values. They compare two. So the purpose of inequality is just to make comparison. Maybe that's the language I should use. They are actually meant to make comparison. So they are mathematical statements that compare two values or two. It's not supposed to be two numbers. They actually compare values or expressions. They compare values or expression. For example of inequality symbols. Inequality symbols now. So these are inequality symbols. Please mute your mic. Mute your mic. So those are examples of inequality symbols. Those are examples of inequality symbols. This is less than faces the left side now. Less than. This one now that faces this way is greater than. A lot of people usually interchange this. Now they miss this for the other. They take this for the other rather. And so now this is less than. The less than symbol This is the greater than symbol. This is greater than or equal to. This is greater than or equal to. Then the other one here is, sorry, I think I missed it. Yes, I missed it. This is greater than or equal to. This is less than or equal to. Less. This less than or equal to. So take note of those things first, those symbols firstly, and that is actually going to help you to understand where we are going. So these are inequality symbols, the inequality symbols that are available. So we can say, if you know these symbols, we can say now that x is greater than 3. This is an example of inequality. This is an example of inequality. So if we say x is greater than or equal to 3, we can also say that x is less than 3, or x is less than or equal to 3. Equal to, this is not among inequality symbol because it is equal. Do you understand now? And there is another symbol called, this is called not equal to. So this is an equality symbol. This is an equality symbol. So when we say x is greater than 3, that means any number that x represents must be greater than 3. It should be, so that means if we say x is greater than 3, it means that x could be either 4, 5, 6, so on and so forth. That is greater than what? 3. So if we say that x is less than 3, that means any number that is below 3 backwards is what? It could be that 2 x, the value of x is actually 2, 1, or minus 1, okay, 0, minus 1, minus 2, minus 3, and it continues. Did you get that? I hope we are following. So if we say that x is greater than or equal to 3, it means that x starts from 3 because it is greater than or equal to. Now these are the things I want you to get. When you say x is greater than 3, it shouldn't start from 3. The number is, they're telling you that the number x is bigger than 3. Greater, like the word implies, greater than 3. So it starts from the number immediately after. So it is successive. The number immediately after 3 is 4, 5, 6, 7, 8. It keeps going. Now, when they say it is less than 3, it means the number that is before 3 and downwards. So any number that is below 3, it could be x. So x can either be 2, it can be 1, x can be 0, x can be minus 1, x can be minus 2, it can be minus 3, it can be minus 4, it can be minus 5. Anything that is less than 3. So negative numbers that follows, even if it is minus 1 million, provided it is minus, it is less than 3. So it goes like that. Did you get that? So when they say it is greater than or equal to 3, x is greater than or equal to 3, it means the value that x has is what? 3, 4, 5, 6, 7, and so on and so forth. Infinite. It keeps going. So when they say, don't forget this, when you see this sign, it is greater than or equal to, it should start from the number that follows. So now what does this mean? X is greater than or equal to 51. James, James. No, James is always my person, so that's why I like calling her name. James, are you there?
Yes, sir.
All right, so when they say x is greater than or equal to 51, tell me, where do we start from?
Okay, we start from 52. Is equals to or greater than 51. 52, 53, 54 till infinity.
Okay, so you still have not gotten it. So when they say it is greater than or equal to 51, equal, it is either it is greater than 51 or equal to 51. It should actually start from what? 51. That means the number x is actually 51. Did you get that now? So I intentionally had to bring that so that it can bring up our mind. So these are the basic things you should grasp. It will actually help you. So it is only, James, now it is only when you say it is greater than if this other sign was not here. If this other sign was not here, then you can now start from what? 52. Then you will not be wrong. Did you get that now? It applies to everybody.
Yes, sir.
Yes, it applies to, but if you put this, it should actually start from what? 51. So the number can actually be 51. X can either be 51 or 52 or 53 or even 1 million. That's what it means. Did you get that now? So, did we all get that?
I got it, sir.
All right.
I got it, sir.
Okay, very well. So I'm very happy that we are all getting it. It gives me joy. So, like I said, equal to is not an inequality. This is another type of inequality. Another example of what inequality is. What this? You write equal and you cancel it, so it means not equal. Not equal. So if I say x is not equal to 3, it actually means that what? X is not 3. Is not 3. It means it is not equal to 3. X can be a particular number that is not equal to what? To 3. Did you get that? So this is another type of inequality. So we have 1, 2, 3, 4, 5. We have less than, we have greater than, we have greater than or equal to, we have less than or equal to, and then we have a not equal. Did we get that? So that is where we are going to call it a day, and that's where we are going to end it today. Yes.
Sorry, sir.
Yes, Memonat. Go ahead, Memonat.
Okay, before we close for today's lecture, thank you so much so far.
Right.
This inequality, I want us to cite example. I don't know if I should give you the example.
Okay.
So that you will explain it. Just one example so that you explain it better for
Okay, so let me take
us.
this out.
Like if A. Okay.
All right.
If A.
Yes.
If A is less than B. And B is less than C.
Yes.
Then A is less than C. Although I understand it, but I want you to also explain it for my fellow colleagues. I don't think everybody understands.
I like that. So if we understood the first explanation, then it will likely be easy to get this. So you are told that A is less than B, and B also is less than C. A is less than B. B also is less than C. That means that A is less than C. So, for example, let's say A. If A is equal to the value of A, for example, is 2. If the value of A is 2, what they are telling you that now 2 is less than what? B. 2 is less than B. So when we say that 2 is less than B, 2 is less than B. What does that mean? It means that the number B should not go beyond the 2. So what is actually the value now? Can anybody answer? What is actually the value there?
3 and above.
Okay.
No, less than. Less than 2.
Is 1.
Yes, it's 1. So 1,
No,
0.
2 is less than B. That means B, the value of B should be like 3, 4, or 5. The value of B.
No, let's get that again. Hold on.
Okay.
Let's get that again now. Now, A is less than B. A is less than B. And I have said that the value of A, for example, is 2. The value of A is 2. So if the value of A is 2, and you are told that A is less than B, that means that 2 is less than B. So if 2 is less than B, what are the values? What are the supposed values of B? That is the question now. What are the supposed values of B?
1. Yes. To me, B.
I mean, it should be greater than.
B should be 3, 4.
Hold on.
It should be greater than that 2.
Hold on.
Yeah.
Let me start with those that their hands are up. Let me start with Ola. Ola, what do you say? Yes, Ola. Okay, let's go to O2. O2, what do you say? Okay, now let me go.
The answer.
Yes, go ahead.
I said the answer should be, the B should be 1 because yes, that is supposed to be 1.
Yes, it's less than 2. Which number? What number is less than 2? What are the numbers that are less than 2? It's actually 1. So it's correct. Memunat, listen to this now.
Okay.
Yes. So the number that is greater
Let me
than.
explain it in my own way I understand it.
Yes.
Yes, I'm understanding it the way Memunat is understanding it.
The question is, if A is less than B and B is less than C, then A is less than C. Let me illustrate it. So let me be telling you the numbers or what you
No,
I
am Memunat, just hold on.
For example, let's say A is indicate A to be that 2. A
Yes.
is the value of 2, quite all right. Then B indicate B to be the value of 4. Then indicate C to be the value of let's say C. Please help me to indicate it so that we will get it clear.
All right, so A is equal to 2. You say B is equal to what?
Yes.
3.
4.
4.
No, B is equal to 4.
Okay.
Then C is equal to 6. Let's say 6. Then the question is like A is greater than B. That is 2 is less than 2 is less than 4, which is okay. And B is less than C, which is 4 is less than C. Then 2 is equally less than C. Then 2 is equally less than C. So this is how the question is and how I understand it. Please, if there's any contradiction.
Okay, all right. So let me take Roland. Roland, go ahead.
Okay, sir. So I wanted to just know what Amara was saying.
Your voice is very low. Speak into your microphone.
I just wanted to confirm what Amara was saying. Explain it as well.
Okay, you are confirming. Let me assume that you are confirming Memunat's. Okay, so Jewel, go ahead. Go ahead.
Okay, I understand it the same way Memunat explained it because just the way she explained it, because the question is A is less than B and B is less than C, then A is less than C. So they are all greater, B is greater than A, C is greater than B, then A is less than C. So that is how I see it as the way she just explained it.
Okay, all right. So let us take it one after the other. This is how this is interpreted. First of all, how do you read this? How do you read this? That means, how do you read this?
A is less than B.
Eh?
A is less than B.
No. So now, your explanation, now listen now, your explanation was okay, but your interpretation of this, for example, if I wasn't someone who sees, if I don't see, for example, maybe we're doing a blind class, you just called me on phone and said, if you say, what did you just say now? You said A is less than C. Is that what you said? A is less than B. Or B is less than
Yes.
A. What did you say?
A is less than B.
A.
A is less than B.
So let us get it right now. So this is now you are saying B is less than A. B is less than A. This is what this means. B, not A is less than B. Is B is lesser than A. Because this symbol is less than. Remember that I gave you something like this. When I gave something like this, what I was saying is that the value of X is actually what? Is lesser than what? Is lesser than 2. So every value that X is not above, it is not above 2. It is not above 2. So this is how you read it. You say 2 is less than X. So that is how you read this one. To B is less than A. B is less than A. So whatever value B has should be lesser than what? A. Are we getting that at all? Are we getting it?
Yes, sir. Very well, sir.
Not for me, sir.
Not for you. Okay.
I think probably because we are reading it from right.
What?
Shouldn't we be reading it from left to right instead of from right?
Okay, well, I can't get you. If there's anybody that heard him clearly, should take it out again.
It's like he's trying to say they are taking it from left to right. That's what I
Okay.
I think that.
So what do we call this now?
For me, what I am understanding is that B is lesser than A, and then C is lesser than B. So it means it's a kind of going back. At last, you have to be that.
No, let us
number.
hold on. Let us start from here now. See what I want you to get. The examples I gave. I'm telling you how to read it like a mathematician. How do you read this? How do you read this now? That's the question. Memunat, how do you read this?
Which one? The S, is it the S greater than 5? That one is greater than.
Exactly.
The S is greater than 5.
Fine. So what is this now?
Yeah. S is less than 5. If we are following the symbol, that means S is less than 5. Whatever the value that S carries is going to be lesser than 5.
Good.
Just the way I said that whatever that A is carrying is lesser than the B. So if we are changing it the other way around, we have to follow this sign.
Yes, that is where.
If we check this material, there is one example that vividly clear this.
No, I am not.
We have to go and make research.
Memunat, I am not against the example. I am very much connected with it. You saw that I had not answered the question. I only asked back. I said, if B is 2, I did not follow the course material. Now I was assuming as if the value of B is 2, based on your question, what will now be the value of A, just like we did here? So if the value of B is 2, so what will be the value here? Because now Yes.
Is 1. The value of B is 2. The value of A will be 1 or 0.
That is the thing. What that is where.
Less than that.
Yeah, that is exactly where I was going. Did you get that now?
Okay.
Yes. So
Yes.
it is about how you interpret it now. That is why I had to bring up this part. So you are now saying, I am not seeing what you wrote in your book or on the board, and you now say, hello, you called me on phone, say, Mr. Solomon, I was doing something. I want you to look at this. And you know, when you were making your statement, I was writing it like this. You say, Mr. Solomon, A is less than B. What you expect me to write is this. If you say B is less than A, if you say B is less than A, this is what I'll write. Are you people getting what I'm saying now? Those are the things I want us to get. So it is the language in mathematics, is how you are communicating the statement. When you were reading it out, you read it this way. You said, if B is less than A, I don't know if that's how you read it as, if B is less than A and C is less than B, then C is also less than A. That's what it means. Did you get that now? So, like we have now said now, if we have it this way, X, 2 is less than A, 2 is less than, what's it called? X. So let us assume this is A and this is B. So if we said initially that if B is 2, what is the value of X? That means X is what? Is actually anything below 2. So we can now say now, for example, I'm going now, we are trying to look at something together. We are trying to look at something together. So just give me your attention. So we can now say that what? A 1 is less than. Are you seeing that now? 1 is less than 2. You are reading it now. 1 is less than 2. 1 is less than 2. Then we now go to B. We have been told that B is 2. So, and you are now saying again here now that the value of C is also less than the value of B. And we are looking at it that the value of B is what? Is 2. So now, how do we express that? So we have to put 2 here first, based on what we have here, based on what we have here, based on what we have here. So we have put 2 here first, then we come here. So which number is less than, what number is less than 2 now? Memunat, what number is less than 2? What number is less than 2?
1.
C is less than B.
1 and 0 is less than 2.
Okay. So,
and even minus 1 is less than 2.
So this is 1 is less than 2. 1 is less than 2. Just like we have here, A is lesser than B. On how we read it now. So what number now would be here is the question now. What number would be here if this one is actually saying that 1 is less than 2. So that means the number that will be here will be a bigger number, because that will now be expressing that this number is less than this number. Are you getting it now? Just like the number that is here is bigger than the number that is here. Okay, go ahead, Memuna.
Yes, sir.
Yes. That's the same thing you were saying.
You say that A is lesser than B, which is the 1 is lesser than 2.
Mm-hmm.
Then you said, is it the B lesser than C? You want us to illustrate with the 2 lesser than any other number?
Give me your value.
If we said 2 is lesser,
give me your value.
If we said 2 is lesser, it can be 3, it can be 4, it can be 5.
Give me your value. Give me the value you have. Just give me your value. What is the value of your A?
If we indicate 2 is less than, I don't understand, sir. Please come again.
Give me your
Where's
value.
the question?
Let me have your value, the value you had, the value you were using to illustrate.
Now let's start with 10. Let's start with 10.
No, let me use, hold on, let's use Memunat. Memunat, give me that value you gave me initially. the value you give me here.
Okay. The A, I said the A is 2.
Yes.
Then B is 4.
Yes.
B is 4.
So that means
C is 6.
so what?
C is yes, 4 is less than 6.
Yes. So what's the difference between this and what we are doing now? I am saying here now, if the value here, which is B, this is B now, is 2 here, which is greater, which is here what? 1 is less than, based on how to read the symbols. I said inequality symbols. The way you read this one now, you don't go ahead and say 2 is less than 1. That would be wrong. So you say 1 is less than 2. Are we getting that now?
Sorry, sir. Sorry to cut you.
Yes.
Sorry, sir.
Yes, I'm here.
Sorry to cut you. The thing is that following this example, which is if A is less than B and B is less than C, then A is less than C. If we are to illustrate it, quite all right, the 4 is less than 6. If you indicate the 4 is less than 6, that means you are saying that then B is less than C. But the question is A is less than C. So it should be 2 less than C. Less than 6, sorry. I know the 4 is less than 6, but following the example there, it's supposed to be 2 is
Okay, Memuna, it's fine. This is A, this is B, and this is C. So now, if the final part says then A is less than C, so what does that mean now? This is A is less than C. It means that 2
is
which
less
is
than
A, is less than what? C, which is very correct now.
C.
I'm just telling you. So the confusion is how to read it. There is no problem with what you have said. The problem is if I said if it was a blind class. When I say blind class now, like I am not writing on the board. We are just doing, maybe we are doing a voice note, for example. The way you read it matters a lot. So if you are saying B is A is what's it called? How do I put it now? 2 is less than 1. That is not correct. It is 1 that is less than 2. So the way you read it now, you say B is less than A and C is less than B. That's not a correct language. The language to use.
That is not how I read it.
Oh,
that was not how I read it.
Okay.
I said A is less than B.
Okay,
and B is less
fine.
than C.
Fine.
Then
Okay.
A is less than C.
All right. Okay, maybe I didn't get you rightly. Okay, so let us just solve it together. Thank you so much, Memuna, for bringing this up. But let us solve it together. This is what you do. How to interpret it. You first of all look at here. The number here, when they say A is less than B, it means that the number B will be bigger when you now represent it, and the number A will be smaller. Once you get this part, you have gotten the other part. So what you intend to do once you see a question like this is, the number, it means that the number here will be smaller because we are saying that what? A is less than B. So you will now say, okay, for example, if the number B here is 3, that means any number that should be here should be smaller than, so it can be 2, it can be 1. So even if I say 2, then I now come here, this is B and this is A. So they now tell me the next thing is that B is less than C. So that means at this point now, if I bring this down here, I should write what? The value of B here, 3, and bring the less than sign. So that means the number that is here, since they are telling me that 3 is less than C, the number that is here should actually be what? Bigger. The same way the number that is here is bigger than the number that is here. So I can now say the number here is what? Is 4, which is now making here C and here is B. So the question is now then A is less than C. A is less than C. So I already have the value of A to be what? 2. I have the value of C to be what? 4. So how do I now write it now? I'll now say what? A, 2 is less than what? 4, which is what? Correct. So whatever value you are putting, the point I want you to get is that the number that is here will be bigger when it comes to less than. The number that is here should be bigger than the number that is here. That's just the rules. Do you understand? And Memunat's explanation was very correct. Do you understand? I intentionally, like I always teach, would always bring up question for us to respond. In your response, we'll be able to now get, just like I sometimes I'll ask, James, what do you say is this one? When she makes a mistake, I will now correct. You see, at that point, we'll now understand there better. I want you to bring up another example so we can round up there. Any other example?
Yes, sir, there is.
Okay, go ahead.
Okay. If A is less than B,
If A is less than B,
A is less than B, and C is negative,
okay, and C is negative. Let's put it like this. It's a negative value, yes?
Then AC is less than BC.
Then AC is less than what? BC.
It's less than.
BC. Beautiful. This is another beautiful one. I like this one.
Sorry, sir. Sorry,
Yes.
I made a mistake.
Okay.
Then BC is less than AC. It's BC that is less than AC. Then BC is less than AC.
Good. So we bring this one down first. A, B. But the first thing in this particular question now, you should consider this. This is a negative. They are telling you that this is a negative integer. The value here is negative. So you must put it into consideration. So first of all, A is less than B. So whatever value B should be bigger in value than the value B. So let us assume that B again is 2. And we'll say 2 is what? Less than 1. 2 is less than 1. But the question here now, this is where you now come back now. It says BC is less than AC. What this means, combining this together, is actually what? Multiplication. Let me write it this way now. So that means these two values, when multiplied together, when B is multiplied with C, it is actually lesser than when A is multiplied with C. So we have gotten the value of A, we have gotten the value of B. What is the value of C? They say C is actually negative. So let us assume a number for C. So let's say C is equal to -3, for example. So if C is equal to -3, now let us now bring that value here. B, we said our B is what? 2. And our C is -3. So 2 times 3 is what? 6. The negative value still remains. So you have what? -6. Less than AC. A is 1. 1 and what? C is what? Please mute your mic. C is -3 again. So we also have what? -3. So we bring the less than sign. So 3 times 1 is what? 3. We still bring down the negative sign. So now, when you do that, you now look at it. When you look at it now, is -6 lesser than -3? That's the question for us now. Is -6 actually lesser than -3?
Yes, -6 is lesser than -3 because minus, when it has to do from that -1 upward, so the higher the number, the lesser it is.
Beautiful.
With the previous one.
Very
Unlike
beautiful.
from 1, 2, 3, like
Exactly.
3 is greater than 2. But from minus 50 is greater than -100.
Good. like I said, I think while I was teaching, I said even if it is minus 1 million. So remember, this is what will help you understand it now. The number system, the number line, actually. Number line, we have 0, we have 1, we have 2, we have 3, we have 4. We have minus 1, we have minus 2, we have minus 3, we have minus 4. I mean, it keeps going. So from here, let's call this x now. From here, it is what? Lesser than. From here, it is a greater than. So from here now, so this means that any value that comes after minus 1 is actually lesser than minus 1. That's what Memunat is trying to say. So 2 minus 2 is lesser than minus 1. Minus 3 is lesser than minus 2 and minus 1. Minus 4 is lesser than minus 3, minus 2, and minus 1. Did you all get that? So remember the number line. Once you remember this number line system, you should be able to know. So even if the number here looks bigger, which shows that 6 is bigger than 3. So, but provided the value of that number, the sign around that number is negative, and the sign around this other number is also negative, it is lesser than. Did we all get that? This one looks, I like what Memuna just brought up for us now. Did you all get that? Is there anybody that has not cleared?
Sir?
Yes.
Sir? Please, let me come in. Although your explanation is perfect, it's perfectly okay. It's like some of us think misunderstand it. I don't know if I can explain it in my own way.
Feel free.
way.
Go ahead.
Okay. Please, I don't know if you can wipe from that A is greater than B so that I will illustrate it with another example. We'll just compare it the way it's going to be vivid for everyone.
A is less than B, yes. Okay.
Okay. Now the question is, if A is less than B, and C is a negative number,
yes,
then BC is less than, is it AC that is there?
Yes, AC.
BC is less than AC. Is it AC that is there, please?
It's AC. It's AC. Yes, AC.
Okay, it's less than AC. Okay, first of all, let's represent the numbers first. A, let's say for example, A equals to 5. Then since B is greater than A, which is A is less than B, since the B is greater, we denote the B to be equal to 7. Let's use 7. And they said the C is a negative number. So negative number, let's say minus 10 or minus, just say minus 10. Minus 10, just indicate it to minus 10. Okay. Then BC, which is B, we have a BC, like that B times C. BC equals to 5 times minus 10. Please, someone should help us to use calculator. 5 times minus 10. Someone should help us with this.
No, it's
5 times minus 10 should be
minus 50.
Okay, thank you. That's minus 50. It's less than, you said this one is AC.
This is BC.
Okay, that is 5 times.
No, BC, you were saying BC is supposed to be.
Which is 7. Sorry, it's supposed to be 7. 7 here. 7 is minus 70. Okay. Then the AC, which is AC equals to 5 times minus 10. Equals to minus 50. Therefore, let's say the BC is less than, here's the BC, that is minus 70, it's less than minus 50. So forget this big 70 that is here. Ordinarily, if it's without this negative sign, 70 is
is greater than 50, but because of this negative, like the tutor explained earlier, because of this negative, the 50 is greater than 70. When you have 0 is greater than -1. So -1 is greater than -2. So that is why we have -70 is less than -50. Thank you.
Thank you so much, Memuna. That was a very powerful section, very powerful explanation. I hope we all got that very clearly. You can use several examples as much as you can. The most important thing is to understand the inequality signs. So I will round up by dropping this for every one of us. Let me round up by dropping this for every one of us. If x is greater than 2, less than like this, 2, x greater than or equal to 2, x is less than or equal to what? 2. This all means, like we said initially, this can mean that what? The number x is of a lower value. So x can be 1 and below. So if x is greater than 2, it means that the number x is above 2. So from 3 upwards. Did you get that? So if x is greater than or equal to 2, it means that the number x can be from 2, 3, and so on and so forth. So if x is lesser than or equal to 2, it means that the number x is what? 2 and below. So it could be what? 2 and minus 1 and 0, so on and so forth, -1, 0, and it keeps going down. Anything that goes below 2, 1, it goes with 1, so it will start with 1. It will start with 1, followed by what? 0, then followed by -1, followed by -2, and so on and so forth. This is what you should use to be able to put at the back of your mind that will help you. And also the number line that I drew for you. The number line 0, 1, 2, 3, 4. And here we have -1, -2, -3, -4. So if this place is x is actually less than the value of x is actually less than anything that is here. If this is x, the value of x is actually greater than whatever is here. Thank you so much for your time. I hope you have a blessed weekend and a blessed night. Enjoy your TMA and come out 10 over 10, everybody. Take care. Bye-bye.
Thank you very much, sir.
Thank you, sir.
Thank you.